and welcome to today's video on significant figures. So as you can see here, I've written out a number. We have 3,751,365. Now, that number is surprisingly accurate for such a large number. And what I mean by that is that we've got detail all the way down to the units column. So if you know from place value, we've got here the units column, which we actually have a digit in. We have a 5. And this number's great if I want to do maths on it. I can do loads of maths, but if this number were a figure such as the population of my hometown, it's probably more accurate than we actually need. It would probably be enough to know that there are about 3,750,000 people living around me. I don't need to know exactly how many, and indeed definitely not all of their names. So this is where significant figures come in. Significant figures allow us to keep enough detail of a number without going overboard effectively. So for example, this number, as I said, is about 3,750,000. And here, as you can see, after the 5 in the 10,000 columns, we've just got all zeros, which they're just there to represent the size. So if we then wanted to put this into standard form, we could. It's 3.75 times 10 to the 6. But how do we actually work out a number to significant figures? This number, 3,750,000, is actually my original number to 3 significant figures, which we would write as to 3SF, or sometimes just 3SF in brackets to the side. This will become quite important, particularly in the sciences, physics and chemistry, where you have to be careful what degree of accuracy you're working with, because you can't become more accurate than the data you're given. But for now, let's focus on the maths side of things, which is writing numbers to a specified number of significant figures. So to write a number to, say, 3 significant figures, we start at the left and we count in 3 numbers. So we've got 1, 2, 3. At that point, everything to the left of that jagged line we're going to take. And we keep the position. What we do next is we look at the next number and we see, is that 5 or more? In this case it's a 1, so it's not. So we don't have to do anything else at this point. We can just replace everything else in our number with zeros. And that's how we get 3,750,000. If we were to instead write this number to 2 significant figures, I'll label that with 3SF. So we count in 2, 1, 2. We look at this number, and this is a 5, and 5 is 5 or more. And what this means is we have to round up. So instead of having 3,7, this 7 then gets rounded up to an 8. At which point we then fill in the rest with zeros. So we know that 3,751,365 is 3,750,000 to 3 sig figures. You often hear significant figures abbreviated to sig fig. I mangled it by going halfway there. Or to 2 sig figs, it's 3.8 million, 3,800,000. So that's for large numbers. So you have a go. Write that to 3 sig figs. And, let's go for it. write that to 4 sig figs. Again, pause the video if you need a bit more time. And once you're done, hopefully you got the answer here. So 4,569,283. We count in 3. 9. So we're going to round up. So it's going to be 4, 5. Round the 6 up to a 7, and then fill in with zeros. For 7,081,902,451. We count in 4. 1, 2, 3, 4. We will be rounding, so it's going to be 7,082. Oh, what is that? And then we fill in the rest with zeros. So to 4 sig figs, it's 7,082,000,000. Now, how about sig figs, significant figures, the other way? What if we had something like 0.08461? Excuse me, bless me, sorry. How do we write 0.08461 to, say, 2 sig figs? Well, you might, if we try what we did last time, 1, 2, we're going to round up. You might be forgiven for thinking it's 0.01. But these zeros are just here to give us a sense of the magnitude of the number. They don't actually have any information other than how large the number actually is. So we do not count those zeros as significant. This is the significant part of significant figures. So what we actually do is we find the first non-zero digit, which here is the 8, and we start counting from there. So 1, 2, then we cut off, round, yes. Okay, we will be rounding up, so it's going to be 0.085. Note, when dealing with decimals, you don't need to put extra zeros in because they're not conveying any information either about the magnitude or the value of the number. So, however, if we had a decimal such as 0.08029 to 2 sig figs, again, we start by taking out those zeros. We know we're going to need them at the end, so we'll put them there. Then we go 1, 2. And you see this 0, although it's a 0, and we've said zeros aren't significant, it is to the right of our first significant digit, which is the 8, our first non-zero digit. And so this 0 actually is significant because it specifically tells us there are no, in this case it's thousandths. So we do have to include this 0 in our significant figures. So when writing decimals to a specified number of significant figures, you put to one side all of the zeros before the first non-zero digit, and then you just count as normal, including any zeros. So here we've got 80, the 2 does not cause a round, so it's going to be 0.080 to 2 sig figs. And yes, this is equal to 0.08, but 0.08 is only to 1 sig fig. If you wrote 0.08 and then put in brackets 2 sig figs, mathematicians, physicists, everyone would understand that you mean that the next digit would be a 0, but it's conventional to actually write that 0 in to show that the number is to 2 sig figs. This is particularly if you do physics or chemistry, you will often find weights such as 50.0 grams. Obviously, the 0.0 is useless, but it's telling you that's accurate to 3 sig figs. So, go on then, your turn. Write 0.0045098 to 3 sig figs, and I'll give you a bit of space, 0.00007008009 to 2 sig figs. Again, pause the video if you need more time, but once you're done you should find, first of all, first number. Take those zeros off to one side or here below because that's where I'm working. Then it's 450, break there, the 9 is going to cause a round, so it's going to be 451 to 3 sig figs. Here 0.00007008009, which is a horrible number to try and say. What is it? It's tens, hundred thousands, 10,000. It's 7 millionths and a bit. It's minuscule, but to 2 sig figs, we're going to take all of these zeros off and then go 1, 2. The 0 is not going to cause a round, so it's just going to be 0.0000070 to 2 sig fig. And very quickly before I finish, I just want to talk briefly about the difference between seeing something like 2SF and something like 2DP. 2SF is 2 significant figures, we know what that means. 2DP, you might be able to work out, is 2 decimal places. So if I had, for example, the number 3.84, that is to 3 significant figures because I've got 3 non-zero digits, but it's to 2 decimal places because I've got 2 numbers after the decimal point. So just to make that abundantly clear, the whole thing is 3 sig figs, but because there are 2 digits after the decimal point, it's to 2 decimal places. And it's important to know the difference just because sometimes in questions you'll be asked, give your answer to 3 significant figures, or give your answer to 2 decimal places or something, and it will expect you to know what that is and to know the difference. Here, as we can see, significant figures is not the same as decimal places. Decimal places, as I've said, I'll say it again, it's very important to know, is anything after the decimal point. So if we consider 0.0000070, that's to 2 significant figures, but if we count, we've got 1, 2, 3, 4, 5, 6, 7 digits after the decimal place, so that would be to 7 decimal places. And again, we use 7DP. Right, so that's it for this video. Hopefully you now all understand what significant figures are, how to work them out, and the difference between significant figures and decimal places. My next video will be on converting between fractions and decimals. But until then, keep doing maths.